forward. So there it is. So on today's agenda, we're going to go over section 3.2 and do some word problem. But before we go there, is there any question on previous sections, like let's say 2.3 or what was the other one? Did we cover 2.4, guys? No, I mean 2.2 or 2.3, meaning separable differential equation and linear equations. Do we have any question on that? I will show you some examples and we shall be a-okay. So let's see. I had a bunch of questions here. Yeah. Does anyone have any questions so far? So I can kind of go over. Let me just switch the camera and, oh, I don't have to do that. Let's just switch. Okay, there it is. So now you can see it. I believe in section 2.2, we talked about separable ODEs, and they were like first order. Okay.
Professor?
Yes.
The main screen you're sharing is very laggy. It's like behind what you're writing on your other screen.
Oh, really? What should I do? Is it because my internet is slow?
No, on like the smaller screen on the side, you know how there's two screens? On the smaller screen, it's fine, but on the bigger screen, it's like very slow.
Oh, really? I don't know what to do.
I guess hopefully it'll just get better through time.
I hope so. I mean, I honestly don't know what to do, but if you can think of something, let me know. But is it clear? The writing clear?
Oh yes, yes, yes. It's just
Oh,
the
okay.
speed.
Oh, it's my Wi-Fi. You know, I have AT&T. We only have like 50 megabytes. So they do have like higher speed, but it doesn't apply to our neck of the woods. So we have very slow internet. And because we have a contract, I can't get out of it. Otherwise, I would drop them on, in a heartbeat. But we're stuck with it. Yeah, I apologize for slow internet. And so basically, let's just do the best we can. Separable differential equations, they have this format, correct? Let's say f of y over g of x, provided g of x is not equal to 0. So therefore, you would separate the variables, write it as dy over f of y, sorry about that. And then you would multiply both sides by dx. Eventually, what you have to do is put the dx where the function of x is, and put the dy where the function of y is. And then you would end up with something like this, g of x. And then you are ready to take the integration of both sides, and you will be on your way to solve the equation. So that was separable ODEs. Do you guys have any question on this, or would you like to see more example of it? Please let me know. So if you are okay, then I can move on. If you are not okay, then we can do some more problems. So what is your pleasure? Please let me know. So what do you think? Are we all okay with separable differential equations, or you are fine with it? Anyone? We good? Should we do just one? Let me see what is on the chat room here. We good. That's Louis says we good. So, okay, if you are good, then I am good. But make sure you are good. All right. So now, I was just going to say that what? That in section 2.3, we have this right here, section 2.3, we have something called what? What was it? Linear equations. Linear equations, correct? And they kind of look like this: a of x, y prime, plus b of x, y, let's say b of x, okay, let's say y is equal to, say, some function of x. So this would be like first order, what? First order linear differential equation. Remember, in general, linear equations should have the following format. Let's say, oh, a sub 0x, nth derivative, and then a1x n minus first derivative, all the way to, let's say, a sub n y of x equals some function of x. So this is pretty much the form of a what? Nth order linear differential equation, which this is like a special case. It's like first order, correct? So how would you solve these guys? Notice, for example, if I have, let's say, oh, you ready? Say I have, say, x squared dy dx plus sine of x minus y is equal to 0. Okay. This is not separable anymore, is it? Not separable. In other words, there is no way we can what? Separate the sine and cosine, can we? I don't see it. So what we have to do is come up with a brand new strategy to solve linear equations. So the first thing we do is provided what? A of x, that is, if a of x is not equal to 0, then you would take this equation right here, and you would divide both sides by a of x. In other words, you go like dividing this guy by a of x, dividing everyone all the way across from left to right by a of x. Why would you do that? Well, because then I would have 1, positive 1, y prime of x plus bx over a of xy equals f of x divided by a of x, correct? So now this, if you would let b of x over a of x to be called, let's say, p of x, and let's say f of x divided by g of x called, I don't know, q of x. So now the equation is y prime of x plus p of xy is equal to q of x. Ladies and gentlemen, this is called standard form. So that's what this guy is called, standard form. Do you see it? Standard form. Okay, so if I have an equation like, say, O dy dx minus, let's say, x, y equals e to the x, that is called standard form. Standard form. How do I know it's a standard form? Because the coefficient of y prime should be +1. However, if I have an example like, let's say, oh, you ready? x squared dy dx minus y is equal to sine of x. This guy is not in a standard form because the coefficient of dy dx is not positive 1. So to convert this to standard form, you would hope and pray to God x is not equal to 0. Then you would divide each of these guys all the way across from left to right by that function. Provided that function, that variable is not, sometimes it's a function too, is not 0. In this case, you would hope x is not 0, because if it is 0, you just divided both sides by 0. So in turns, you get dy dx minus 1 over x squared y equals sine of x over x squared. Now we have the equation in standard form. So the question is, look, these equations are not separable. So how would I go about solving this? Because if they are not separable, I don't know what to do, correct? So it turns out to solve these kind of equations, we need a function which by multiplying that function both sides of the equation, then this problem becomes solvable. In other words, it will be somehow separable. What I mean by that is the following. Just suppose we have the general standard form, which is y prime of x plus p of x, y is equal to q of x, correct? I need a function called an integrating factor, which some books, they use the notation Greek letter mu, that's how you pronounce this. It's a lowercase m in Greek letter, or sometimes they just use capital I. So it is called an integrating factor, which is denoted by mu, and it's a function of x or function of whatever the variable it is in your equation. And it is called integrating factor. And by definition, integrating factor is e to the power of antiderivative of p of x dx. So this is how the integrating factor is defined. So what you do, you take the coefficient of y, not y prime, including the sign, and raise e to the power of integral of that function. Don't forget the sign, yes. And that is called integrating factor. Turns out, if you multiply both sides of that equation by this magic function called integrating factor, lo and behold, the left side, all of a sudden, when you multiply, it becomes the derivative of the integrating factor times the function you're trying to solve for equals whatever this guy is. So that's the beauty of it. The minute you multiply both sides by integrating factor, the left side becomes the derivative of the product of the what? Integrating factor, and the what? The unknown function. Once you get to this point, you multiply both sides by dx, like so. Okay, like so, mu of x times q of x dx. Now you're ready to attach antiderivative sign. And on the left side, you get mu of x times y of x plus whatever this guy happens to be, right? Then you would integrate this. At the end, what you would do to find y of x, and don't forget, you're gonna, when you integrate this, you're gonna get some function plus c, then you would divide both sides by this guy. Do you see it? Including the c. Don't forget the c. Let me see, there's a chat here, if there's any comment. Sorry, Professor, I have to go pick up some, okay, yeah, no problem, yeah, okay, yeah. Okay, let me just answer this. Okay, no, okay, okay, very good. Right. So this is pretty much the procedure to solve first order linear differential equations, of course, ordinary differential equations, single variable. So do not memorize the procedure because it doesn't make any sense to memorize it. Let me just show you an example so you can follow the steps. Do not memorize any formula. It just doesn't make sense. All right, so if it's okay with you, I shall solve a problem. So here it is. The question is this. Suppose you have what? dy dx, okay, minus y is equal to minus e to the power of 3x is equal to 0. Okay, here's the equation. The question is solved. And once again, if there is a plus or minus between x and y, usually the equation is not separable. If it is not separable, the only way I know how to do this, I would pray to God that this would be what? Linear. Because if it is not linear, and if it is not separable, then I don't know how to do it. Then I have to stay tuned for upcoming chapters. But right now, I have only two formats. Either the equation is separable, so I can separate the variables and take the integral and get on with my life, or it has to be linear. There is no third scenario for us, because if there is a third case, which is what? Not linear, not separable, then I have to come up with plan C. This guy is linear. Why? Because if I put this function on the other side, I get dy dx minus y is equal to e to the 3x. It fits the description of the linearity perfectly. Check this out. This was the general form, correct? This was the general form. Looks to me, what do you think my p of x is in this case, guys? Could someone please tell me what my p of x is? Anyone? Let me see what you got here. Chat. Yes, it is -1. Don't forget the sign. So your p of x is a constant function. And what is my q of x is e to the power of 3x. Is this separable? No, it's not. If it was, I could have solved this a long time ago. It's not. So it is linear. It is in a standard form. I identified the p of x, so now I have to find integrating factor. Integrating factor. Okay. What is it? By definition is e to the power of antiderivative of p of x, which is -1 dx. Why is it dx? Well, because the independent variable is x. Had that been like dy dt, then this would be -1 dt, then integrating factor would be a function of t. So it all depends what your independent variable is. Okay, so the integrating factor will be always a function of that independent variable. Anyway, so what is this? This is the same as e to the power of -x, correct? -x. This is my integrating factor. Is that right? Now, some of you might say, hey, whatever happened to the c here? Well, I could have c plus c, but I'm not going to write c. Why? Because I need only what? One integrating factor. So I'm going to set c equal to 0. You could also set it equal to 103, but 0 is the best number you can come up with. Because I need one and only one integrating factor, so I'm going to set that c, which I'm going to get here, equal to 0. So this is what I need, okay? I don't need too many integrating factors. I only need 1. All right, so I'm going to multiply this equation, both sides by e to the negative x. So e to the negative x, you multiply both sides of the what? Of the equation in what? Standard form. You see it. So there it is. Okay, someone has p of x is negative y. It's not. P of x is the coefficient of y, which in this case, it is negative 1. It's not negative 1y. Be careful. All right. So now, guess what? This guy is e to the negative x dy dx minus e to the negative xy. I can add these guys up. E to the x times e to the y is e to the x plus y. So this guy is e to the 2x. You see it. But remember what I said. The minute you multiply the what? Both sides of your linear equation by integrating factor, the left side of your equation becomes always rain or shine. So let me just write that down. Always what? The derivative of product of your integrating factor, which was e to the negative x, and the function you're trying to solve for, the unknown function, which is y. You don't believe me? Let's, before we move on, check. Let's check and take the derivative of this product and see if it's this. Okay, because this is product of two functions, so I have to use the product rule. What is the derivative of the first guy? Is negative e to the negative x times y. Okay, derivative of the first times the second. What is the derivative of y with respect to x? Y prime, or dy dx, times the first. Isn't that exactly what we have here? So this is not a happy coincidence. It always happens. The minute you multiply both sides by integrating factor, the left side becomes derivative of the integrating factor times the unknown function you're trying to solve the equation for. However, the right side stays the same. So now I can separate the variables. How? Multiply both sides by what? By dx. Okay, get this. And now you are ready to attach integral sign to both sides. You see it. But this antiderivative neutralizes the derivative. What you get is what's inside the brackets, which is e to the negative x times y. Remember, this is multiplication. But now you have to integrate the right side. The antiderivative of e to the 2x, I believe it is half of e to the 2x. Don't forget the c. Are we done? Not quite. Now I have to get rid of this guy. How do I get rid of that guy? Either you multiply both sides by e to the x to get rid of this, or realize you can write the left side this way. Okay. Then that kind of shows you, hey, to get rid of this, you have to multiply both sides by e to the x. Okay. So multiply both sides by e to the x, so I can solve the equation for y. Because right now I have, you remember this form, it's called implicit form. I'd like to put my final answer in explicit form. So I'm going to say y is equal to what? Half of e to the 3x, 2x plus x, plus c times e to the x. Notice I need to multiply that guy by c as well. So don't leave the c, correct? And believe you me, that would be the final answer for this problem. And this is called explicit form. Why? Because somehow miraculously I managed to solve the equation, the answer, the solution for y. So I was able to put the y on one side, everything else except y on the other side. That's called explicit form. And usually they want you to put the answer in this form if possible. If not, then there's not much you can do. Do you all see it? Is there any question? We good? So this would be the video on section 2.3, how to solve linear differential equations. Let me do one more because tonight we like to do some word problems and those guys usually take time. So let me just do one more. Are we okay with this problem, guys? Any questions, any comments? Was there something between here and the end which you didn't quite get so I can go back and explain? Are we okay? We good? Yeah. So, so the idea is what? Let's pick one more. Let's just say you have this guy. Solve t squared, okay, t squared dx dt, okay, plus 3tx equals t to the 4 natural log of t plus 1, and this guy has an initial condition, x of 1 is equal to 0. To begin with, let's not worry about what this is and how to solve it. What do you think I'm trying to solve for? Could anyone tell me, please, what is my unknown function in this case? When they say solve, what am I solving for? Which variable am I solving for? Anyone? Koa, x? Good. Yes, solve means find a function of what? X, a function of t. That's what's missing. Remember, what goes on top of the derivative is that's what you're solving, and whatever it is that you're finding is going to be a function of t. So, is this linear? It looks like it because you got, you know, in this case, you got a of t, what? X prime of t plus what? This is like a of 0, a of 1, what? X of t equals what? Some function of t on the right side. So it fits the description of linearity, so we are good to go. Even though I don't have a dy dx, so what? You don't get dy dx always. Sometimes you get dx dt, sometimes you get dw ds. So the idea is, do you recognize this is a linear equation? So it falls into this category, but now the functions are functions of t as opposed to x, because x is the unknown function. So first thing you do, you would hope and pray to God t is not equal to 0, and then you divide what? Each side by what? By this guy. Because in order to put the equation in a standard form, you want to make sure this coefficient is 1. So dividing both sides by t squared, that's what I'm going to do. I'm going to get dx dt plus what? 3 over tx equals what? T squared natural log of x. Don't forget the 1. There it is. So now, ladies and gentlemen, this is called standard form. Do you see it? Standard form. So I'm ready to go. But guess what? I need that magic function called integrating factor. But my integrating factor here is no longer function of x. It's going to be function of t. Okay, the independent variable. So don't put mu of x, you know, rain or shine. Look at your independent variable. So the integrating factor has to be a function of your independent variable. In this case, is t. But what is my p of x? Does anyone see it? What is my, excuse me, P of t? What is my P of t? Remember right now is dx dt plus P of t x equals Q of t. That's what I have right now. So question is, what is my P of t? Let's see, Koa says 3 over t, which is nice, but may I remind you, don't forget to take the sign. I will show you if you don't take the sign, what happens in 1 sec. Let me just do this. So by definition, this is e to the power of what? Positive 3 over t dt, not dx. So the answer is e to the power of, you can pull the 3 out, and this is dt over t. But you and I, we both know this guy is natural log of t. Now, what do I do with the 3, which is next to the natural log of t? Put the 3 where it came from, and put it on top of t as an exponent. So this would be e to the power of natural log of t cubed. But remember, e to the power of natural log of any function is that function itself. So in this case, e to the power of natural log of t cubed is t cubed. Folks, this is my integrating factor, which I have to multiply both sides of this equation by to make it separate. Do you see it? Now, let me make a comment about not taking the sign seriously. All right, so imagine you had dx dt minus 3 over tx, whatever. So if I go, the integrating factor is e to the power of 3 over t dt, remember the answer came up to t cubed. But this guy is not 3 over t, is minus 3 over t. Don't forget the sign. Okay, so this is not the integrating factor for this guy. The integrating factor for this guy is e to the power of minus 3t dt. And guess what that minus does? It changes this guy like 180 degrees. Check this out. So this would be e to the power of, pull the negative out, what? Antiderivative of dt dt. You and I, we both know that is still natural log of t, correct? But now if you move this negative 3 and place it on top of t as an exponent, you would get e to the power of natural log of t to the power of negative 3. So the answer is t to the power of negative 3, but guess what it is? It's 1 over t cubed. Do you see the difference? So it's very crucial that you what? Take the sign along with your p of x. Don't just take the function. Pay attention to the sign, because if you forget the sign, you will get t cubed as your integrating factor, when in reality the answer is 1 over t cubed. Do you see it? Because of that minus sign. So it's very important you take this sign serious, because it will give you totally different what? Integrating factor. Okay, so what am I supposed to do now? I'm supposed to take this as standard form, which was this guy, okay, and this is t squared natural log of t plus 1 over t squared. Multiply both sides of the equation by my integrating factor, which is a function of t, mu of t, not x. Okay, if you distribute both sides, so you get t cubed dx dt plus what? 3 over t squared x, is that right? Or is it t squared? Sorry about that. So it's getting a little bit late at night. So there you go. And what? On the other side, I have what? T to the power of 5 natural log of t plus t. Did I do that right? Are we good? Does anyone see it? Do I have your approval? I didn't make any mistake today, I hope. No, I think we are good. Remember, the left side is always derivative, in this case with respect to t, not x, of what? Of your integrating, the product of your integrating factor and the function you're trying to solve the equation for. So keep in mind, the minute you multiply the standard form of a linear equation in first order by your integrating factor, immediately the left side becomes what? The derivative of the integrating factor times the unknown function. You don't believe me? Check this out. Derivative of this guy is 3t squared times x, plus derivative of x with respect to t is dx dt times t cubed. There it is. There it is. Take the derivative of this product, see for yourself, you get the top. So this is not a magic steps. It really comes up to the derivative of what you had in previous step. All right, so the left right side is still t to the fifth natural log of t plus t. Now I can separate the variables by multiplying both sides by dt, correct? And here I get t to the 5 natural log of t plus t dt. So there it is. Now it's time to what? Attach the integral signs. Okay, so prior to this, I couldn't do it. The minute you put the equation in differential form, then you are good to go. Left side is easy because the antiderivative neutralizes the derivative, so what you get is t cubed times x. Right side, we have a little work to do, guys. We actually have to what? Integrate this. So that's where we are. So the minute you finish the integration here, you can solve for x, and that was the basic idea. However, let's just see if we can quickly finish this and then go from there. So, question, how do you integrate this right side of the equation? In other words, how do you integrate t to the fifth natural log of t plus t dt? Well, remember, this is product of two functions, so it looks to me here, I have to use integration by parts. So I'm gonna let u to be natural log of t, dv to be t to the fifth dt. Remember the formula, it was u dv equals uv minus antiderivative of v du. That was the formula for integration by parts. When do we use integration by parts? When you're integrating the product of two different functions. So from here, you take the derivative, which is du dt is equal to 1 over t. So du is dt over t. From here, you take antiderivative of this guy, so you get t to the 6 over 6. Now use the formula uv minus antiderivative of v du, you get what? uv, which is what? T to the 6 over 6 natural log of t minus v du, which is t to the 6 over 6 times dt over t. Is that right? So now, and don't forget this guy. So remind me to integrate that as well. So right now I'm just working on this portion of the problem. So this would be t to the 6 over 6 natural log of t minus, one of the t's cancels here, you get t to the 5, excuse me, 1 over 6, but you still have t to the 6 over 6. And then the integral of t is t squared over 2. Now it's time to put a c. And what was on the other side of the equation, if you remember? T times x. So this is excuse me, what you get. It's a mess, I know, but it is what it is. Excuse me. But provided t is not equal to 0, now I have to solve for x. So what you do is divide each side by t, so you get t to the 5th over 6 natural log of t minus 1 over 36 t to the 5th plus what? T over 2. Don't forget to divide c by t as well. So please do not forget this step, because sometimes students write the c when they divide both sides the function attached to the unknown function, they forget to divide the constant by that function as well. So now we have the answer in explicit form. Do you all see it? We had an initial condition, x sub 0 is equal to 1. Remember what that means. That means when t is 0, x is 1. So replace the x with 1, all the t's, excuse me, I think it was the other way around. X sub 1 was equal to 0, sorry. So that means when t is 1, x is 0. So replace all the t's with 1. Remember, natural log of 1 is 0. Okay, so this is negative 1 over 36. This is 1/2, and this is c over 1. Solve for c, whatever it is, substitute here, and then you would have, this is called general solution, but the minute what? You solve the equation for c, you find out what c is. I don't know offhand what c is, whatever, some number. So this would be called particular solution. You see it. And particular solution is one of a kind. In other words, everyone should come up with the same answer and same C. Do you see it? So that's called general. You have a constant. And notice the order of differential equation was 1. So we had 1C. And we have one initial condition. So that makes sense. Initial condition is given to you so you can find out what C is. Find out what this guy is. Plug it back here. Box your answer. That would be your particular solution. Are we all good here? Do we all see it? So that's basically the idea behind what? Linear equations. I hope you have watched the video, so please practice. I know when you watch me doing it, you go, oh, okay, I can do that, but try to do it on your own. See if you can still do it, and that way you can learn how to do these kind of problems. This is section 3.2. Let's do a couple of word problems before we run out of time, because these guys take a little bit of time. The first problem is called Newton's what? Cooling law. Okay, so there it is. What does it say? It says that the rate of change of temperature of the body is proportional to the difference of the temperature of the body and the temperature of the surroundings. So this is surrounding. The reason they use M, because M stands for medium, which means surrounding, like, you know, room temperature or the temperature on the beach, wherever the experiment was conducted at. Okay, here is the deal. A glass of water whose temperature is 50 degrees Fahrenheit is taken outside at noon, that's 12 p.m., on a day whose temperature is constantly 70 degrees. So this is your Tm. So this is your outside temperature and it's constant, so it's fixed. If the water's temperature is 55 Fahrenheit at 2 p.m., okay, do you expect the water's temperature to reach 60 degrees Fahrenheit before 4 p.m. or after 4 p.m.? Use Newton's law of cooling to explain your answer. In other words, don't guess, do some mathematics. Okay. So basically, I have the following information. All right. You ready? At noon, I'm going to pretend this is my reference time. So I'm going to pretend that is when time was equal to 0. So this is my reference time. So the entire experiment started at noon. So I'm going to pretend that's 0. At noon, what? The temperature was 50 degrees. 2 hours later, at 2 p.m., 2 hours after what? 12 noon, the temperature, what? Warmed up to 55 degrees. Do you see it? Yeah, because it says so, right? I'm just writing the information given in the problem. So I like to see, what do I have? What am I trying to find? The question is, do you expect the water's temperature to reach 60 degrees before 4 a.m. or after 4 a.m.? Meaning, I'm trying to find the time when the temperature of the what? Water reaches 60 degrees. So it looks to me in this problem, the time is missing. Once I figure out what the time is, then I can answer this question. Was it before 4 p.m. or after 4 p.m.? So let's begin. The room temperature, TM, is 70 degrees and it's Fahrenheit, and it never ever changes. It's, notice, says constant. Okay, so if you kind of stick that in the formula, you get minus K T minus 70. Believe it or not, this is separable differential equation. So separate the variables, divide both sides by 70 minus T minus 70, keep the negative K on one side, multiply both sides by dt. Okay, so it's a separable differential equation. So I separated the variables. I put the capital T where capital DT is. I put the lowercase t where there was a K. Integrate. Believe it or not, if this is U, T minus 70, du is dt, which you have it on top. So this is kind of like du over u, which is natural log of what? T minus 70. On the right side, you get minus k, t, don't forget you have a constant. Somehow I need to solve this for t. How do I do that? I would exponentiate both sides, meaning raise e to both sides of the equation. Why would you do that? Because e to the power of natural log of something is something. So I can get rid of the natural log. So this step is called exponentiating both sides. So on the right side, I get this, okay, I get e to the negative k plus c1, but I can split this into e to the negative k times e to the c1, and I can call this guy capital C, because c1 is constant, so is e to the c1. Why don't we just call this C? Technically, you get plus or minus because of the absolute value here, but you can call what? Plus or minus e to the c1 a capital C. So let's not worry about absolute value, so you know where this C is coming from. So what I'm saying is, this guy becomes C times e to the negative t. So now I almost have the equation, except I have to know what C and K is. To find C and K, I have to impose these conditions. The first condition is when T is 0, temperature is 50. So go 50 minus 70, replace the T with 0. Lo and behold, C becomes negative 20. There it is. You got the C by imposing this condition. Okay, so now the equation looks like this. T minus 70 equals negative 20 e to the power of negative kt. Now I have to find k. How do I find k? I impose this condition. 2 hours later, the temperature of the glass of water warmed up to 55. So I'm going to replace the t with 55. And I'm going to replace this lowercase t time with 2. Now my job is to solve this equation for k. How would I do that? I don't think I have enough space. If you don't mind, let me take a clean piece of paper so I can what? Solve for k. So here's what we have. What do we have? We got 55 minus 70 is negative 15. This is negative 20 e to the power of negative 2k. First thing you do, immediately divide both sides by negative 20, correct? And that would give you, say, 3 over 4 equals e to the power of negative 20. Take the natural log of both sides because you want to get rid of that exponent. Okay, like so. So the left side stays as is, but the right side, I can liberate the negative 2k and place it next to the natural log and write it as negative 2k times natural log of e. But keep in mind, natural log of e is equal to 1. So this guy is 1. So k becomes negative half of natural log of 3 over 4. So there it is. So we got the k. If you like, you can what? Keep this in exact form and move on with your problem. So with your solution. So therefore, right now we got what? T minus 70 minus 20 e to the power of minus what? Minus k, which is that guy, but minus, there is a minus in the formula, and there is a minus the value of the k, so that makes it positive, I believe. Is that right? Oh no, where am I? No, that was, where is my k? It's right there. So what would I get? I would get, is that positive or negative, guys? Where am I? It's negative, right? And k came up what? To negative as well. So I would get negative 1/2 natural log of 3/4 times t. So this, ladies and gentlemen, is called complete mathematical model. So I took numbers, I convert them to equations, so now I can predict the future. So my equation right now reads t minus 70, negative 20. I can multiply t by 1/2, so negative times negative is positive. So this is t over 2, natural log of 3 over 4. Is that right? Guess what? I can put the t over 2 on top of 3 over 4. A lot of properties of logs are used in this problem. 3 over 4 to the power of t over 2. But remember, natural log of something is something, so you get t minus 70, negative 20, times what? 3 over 4 to the power of t over 2. This is as good as the equation gets. What was the question? What am I trying to solve? You know, I don't want to get lost in the middle of the jungle without knowing what I'm after. What I'm after is the missing time when the glass of water reaches 60 degrees Fahrenheit. What does that mean? That means replace this guy with 60 and try to solve this equation for t. Okay, so this would be like negative 10, that would be like negative 20, this would be like 3 over 4t to the power of t over 2. Divide both sides by negative 20, so that would be 1/2. This would be what? 3 over 4 to the power of t over 2. Okay, this is called exponential function. To solve exponential functions, we take natural logs. So you can either use natural log or use log of base 10. It's entirely up to you. So if you use natural log, like so, guess where t over 2 goes? It goes and sits right next to the log. So you would have natural log of 1/2 equals t over 2 times natural log of 3 over 4. So now solve this for t. Multiply both sides by 2. Okay, so you get what? 2 times natural log of 1/2 equals t times natural log of 3 over 4. So T equals 2 times natural log of 1/2 over natural log of what? 3/4. Work this out on your calculator, and you will see the answer is going to be what? Let's say 2 times what? Natural log of, what was it? 0.5. Get an answer. Divide that by what? Natural log of, what was it? 0.75, which is, 3/4. And you would get what? T is roughly equal to 4.8188 hours. So what does that mean? So what did we find out? Was the temperature of the glass of water 60 degrees before 4 o'clock or after 4 o'clock? What do you think? With this answer, what do you think? Anyone? So did the temperature of the glass reach what? To 60 degrees before 4 o'clock or after 4 o'clock? After 4 o'clock. You know why? Because this say you were this many hours after 12. Believe it or not, if you take this decimal portion and multiply it by 60 minutes, because 1 hour is 60 minutes, the time was what? 4:48 p.m. So take this decimal portion, multiplied by 60, because 1 hour is 60 minutes, so you can tell exactly what the time was when the glass of temperature reached 60 degrees Fahrenheit. The time was 4:48 p.m., which is way after what? 4 o'clock. You see it. Boy, it took a lot of work to get there, didn't it? Unfortunately, that's how these problems are solved. They are not quickie problems. And I don't think I can do all of them tonight. I'll leave some of them for Thursday. This is just one. So think of this as a mechanical engineering problem. The ones who are going to take, let's say, thermodynamics or fluid mechanics. So there you have it. Okay, the next problem is for EE majors. So I'm trying to make everyone happy here. Okay, consider RL circuit with resistor equal to 4 ohms, and L stands for inductor, which is 0.4 henries. That's the unit for inductor. This is the unit of measurement for resistor. And the E, which stands for electromotive force, which is the voltage source, is 20 volts. If there is no current in the circuit initially, determine the current in what? At any time greater than or equal to 0. So this is called RL circuit. So usually an electrical circuit looks like this. You have a voltage source. You have some elements. In this case, you have, right, resistor and inductor, and this is your EMF, electric motive force, which is your what? Source of what? Voltage, which in this case is DC volt, because if it was AC, then you would have a sinusoidal function. This would be like 20 times sine of t, but it is constant 20 volts, so it must be a battery, 20 volts battery. Because this is a closed circuit, and that's what the assumption is, so a current kind of flows into the circuit. I don't know if you are familiar with circuits, but basically we have a resistor, and the voltage across the resistor is what? Ri, and that's called Ohm's law. Okay, so if you want to know how much voltage goes through the resistor, by the way, resistor resists the flow of the current. That's what this guy is. Then we have something called inductor, So this is L. Okay, so the voltage across the inductor is L di dt. And L, the unit for L is what? Henries. And what does L does? It opposes any changes in the what? In the current. So it opposes any changes. This guy resists the flow. Then we have this guy, okay, which is called capacitor. Capacitor stores electric charge. So the voltage across the capacitor is 1 over CQ. Q is the electric charge, so it's electric charge, and the unit for that is coulombs. And guess what? I, the current, is how fast the electric charge changes with respect to time. So that's how Q is related to current. And this guy is the current, and the unit for current is ampere. Okay, so these are the essential information. It will be nice to know so I can solve this problem. One more piece of information I need to know. I don't know if you guys have heard of this. Has anyone heard of the gentleman, his name was Kirchhoff, and this is called Kirchhoff's second law. Has anyone heard of this in physics classes or anywhere else? Kirchhoff, Russian electrical engineer. Kirchhoff, yes, you have. What does it say? It says if you have a closed circuit, the sum of the voltages, okay, voltages around any closed, what we call in electric classes, closed loop, should add up to 0. So that is Kirchhoff's law. The sum of the voltages in a closed loop, that means in a closed circuit, so it's not open, it should add up to 0. So what do we have? Here we got what? What was the ohms here? I think this guy was 4 ohms, and this is the notation for ohm. This guy was 0.1 Henry, and we show the Henry by capital H. And the voltage source was 20, okay? So, and you have to follow the polarity. So in other words, this is positive, negative. I'm just following this notation, positive, negative. So go around the circuit and what? Find the voltage across these elements by these formulas, correct? And then add the voltages, set it equal to 0 because Mr. Kirchhoff says the sum of the voltages in a closed loop should add up to 0. So with that said, let me just quickly do this, and then we are so good to go with this problem. So here is the diagram one more time. Excuse me, guys. Trying to rush this. Okay, so this guy was resistor. That's how you show resistor. 4 ohms. This is called inductor. And this is electric what? Voltage source, which is 20 volt, and there is a current flowing into the circuit. We like to find how much current do we have, how many amperes. Okay, here's what you do. Right here, the voltage across from here to here is 4I. Remember, I is a function of time. Here is what? L, which is 0.1 times di dt. That's the voltage across these 2 points. And then you hit this guy, but notice you hit the negative polarity, so it's negative 20 volts, set it equal to 0. In other words, what Mr. Kirchhoff said was what? The sum of the voltages on the resistor and the inductor should offset what? The voltage source, okay? So believe you me, this is a linear, what? First order ODE. Why? Because it looks like this. It looks like A of t 0, what? I of t, excuse me, guys, right there. A of 0t di dt plus a of 1t I of t equals some function of t, which in this case, that function happens to be constant 20. So it is linear. So if you don't mind, I'm going to rewrite the problem. 0.1 di dt plus 4 times I equals 20. Remember, we're supposed to put the equation in the standard form, so immediately divide both sides by 0.1. Okay? When you do, you get di dt plus what? 40 I equals what? 200. Is that right? What would be my integrating factor here? E to the power of, this is my P of t, don't forget the sign, positive 40 dt. So I would get e to the power of 40t. Okay? So multiply both sides of this equation by e to the power of 40t. You know, this equation right here, the one which is in a standard form, di dt plus 4i e to the power of 40t and times 200. Remember, the minute you multiply the left side by integrating factor, this guy becomes derivative of your integrating factor, which is e to the power of 40t, times the unknown function, which is the current. But I still have 200 e to the what? 40t on the right side. Separate the variables, multiply both sides by dt, and take the integral of both sides. So, if you don't mind, let me just take a clean piece of paper. We are almost there, guys. So, kind of, I don't know if you guys can see it. Multiply both sides by dt. Okay. And you get 200 e to the power of 40t dt. Attach integral signs. The left side is what you have inside the brackets. The right side is an easy integral because 200 is constant. And this guy is 1 over 40 e to the power of 40t. Don't forget the c. Question is, if you would divide both sides by e to the 40t, if you divide, what would you end up with? I of t equals what? This would be 5, what? Plus, is that right? C over e to the power of 40t. Is that right? So this is so many amperes. But wait a minute, I need to find C. The problem said initially there was no current, so that means I of 0 was 0. So I'm going to replace the t with 0, I with 0, correct? To find C. So that's 0, that's 5, and that is C over e to the 0. C is equal to -5. Remember, e to the 0 is 1, right? So this is 1, move this 5 over, you get -5. So I of t is equal to 5 minus 5, what? Divided by e to the 4t, which you can write this as I of t is equal to 5 minus 5 e to the -4 dt, and the unit is ampere. There it is. Just a quick follow-up. What happens over long run? In other words, in a long run, what happens to the current here? Can someone tell what might be the amount of current in the circuit if you let the electricity, the current flow into the circuit? What would be the long run current? In other words, in a long period of time, what happens to the current? Does it become 0 so you can touch these elements so you won't get electrocuted? Or would you have some current left? Anyone? What is it, Sophie? 5. Yes, indeed. Yes, indeed. Thank you. So when you say take the limit, what you're saying is take the limit of I of t when t approaches infinity. So this is long run current. Okay, so when you take the limit of I of t when t approaches infinity, you take the limit of 5 minus 5, what? E to the negative 40 when t approaches infinity. Remember, this guy is in the denominator, like so. When the denominator goes to infinity, this whole thing goes to 0, so you get 5 amps left. So what does that mean? Even if you unplug the whatever this device was, please do not touch the the electronic devices inside the appliances or whatever this object was, because you still have current in it, so you might get electrocuted. So be very careful. So even though you unplug this circuit or you disconnect the voltage source, but in a long run, you still have 5 amps left. So be very careful. So with that, guys, have a great night. Take care of yourself. See you all Thursday. So if you have any question, I'll stick around for 5 minutes. Good night, guys.